Hello guys, here Mr. G with another video for the grade 12. This time we're going to be solving a question on chemical or organic reaction, which could be quite tricky for the exam. This one is question 4 from 2016 June examination done at the Northern Cape. And before we do that, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question said the flow diagram below shows the conversion of alkane X to different compounds, and you have the reaction there. You start with an alkane and you have different directions there. For reaction 1, now in reaction 1 guys, you can see here one reaction condition and the IUPAC name of compound A. But reaction 1, let's first of all identify. Now in this reaction you start with an alkane, so from alkane you go into a bromine, which is a single bond compound. So this reaction 1 is substitution. That is for sure. Remember, substitution reaction, I'm going to write it here. You starting with a single bond and you will end with a single bond. That is important. And you have alkane, which is single bond, and you adding a bromine. Okay, so this one is the reaction, is substitution reaction, and in this case is going to be halogenation because you adding halogens there. Now to identify the type of reaction is quite important, otherwise you will struggle to answer this question. Now the reaction conditions here is heat or sunlight. One reaction condition, I'm going to write both of them, heat or sunlight. Heat or sunlight, those are the two conditions for this type of reaction. Name of compound A. One of the hydrogen is going to change places there, guys. Now, important, what alkane are we having here? We have butane. Now, how do I know it's butane? I went all the way to the back here and I have here butene. I end up in butene, guys. The number of carbons will remain constant. At least you have here another type of reaction like cracking, for instance, but there is not cracking, therefore the number of carbon will remain the same. So it must be butane, and then you add in Br2. I wanted to show you this reaction here, what is happening. Guys, this bromine, one bromine will change places with one hydrogen. But the hydrogen that will change place with the bromine will be the hydrogen that is in the carbon with least number of hydrogen. So it will be that hydrogen there. So what is happening here, the bromine will take the place of the hydrogen, and this hydrogen will take the place of the bromine as it is here. So what we have in the product will be the but with the 4 carbons here, but the bromine will be on this side there, and then obviously the hydrogen took place. So here it must be plus HBr. This is the compound, guys. So what is the name of this organic compound? The bromine is in the second carbon, so it's 2-bromobutane. It's quite simple, but that is the name in case somebody didn't remember. So that is the answer. Question 4.2. Consider reaction 2. Now we are going to reaction 2. We are going from a haloalkane, compound A is a haloalkane, to an alkene. So this one is going to be elimination reaction. This is elimination reaction. Guys, remember, an elimination reaction, in elimination reaction, you start with a single bond and then you end with a double bond. That is elimination reaction, how you can identify there. In this case, you are going to take or get rid of the hydrohalogen, so this one is dehydrohalogenation. This is dehydrohalogenation. The question say, consider the reaction 2, write down the type of reaction. I'm going to write elimination. Now, why I'm not going to write dehydrohalogenation? halogenation, because for sure I know it's elimination, but I may get confused in terms of the hydrohalogenation. So I'm not going to write the type of elimination, but I'm going to write elimination so I can get that mark. Structural formula of the chain isomer of but2ene. Now this one is not necessarily related to the reaction. But2ene is already known there. They want the structural isomer of but2ene. So they want the structural formula of the chain isomer of but2ene. Now this one here is but2ene. How can I get the structural or the chain isomer of but2ene? So I'm going to change all this one here, guys. All this one here, I'm going to change the place and I'm going to place it perhaps there. Okay, so that's all I'm going to do here. And here we are, we change the place of that branch, the little branch, and we make a branch actually, because at the beginning was not a branch. So this is the chain isomer of that but2ene. This one is chain isomer. Chain isomer. Let's go to the next question. Question 4.3. Compound B is produced of reaction 3. So let's look at reaction 3. Now reaction 3, you are adding water. You are adding water to a alkene. That one is addition. And because you adding water is hydration, going to be, guys, quite simple here. Hydration is the type of addition that you have there. We must know that in addition, you will start with a double bond and you will end in single bond. This one here will help you to identify the main type of reaction that take place there. So we know it's addition, and in actual fact it's going to be hydration. You are adding water, as you can see it there. But let's see the question. The question say, is compound B a primary, secondary or tertiary alcohol? There is a video on that one. I'm going to leave the link. Give a reason for your answer. Okay, so compound B, now we're having but2ene. So let's go to see the reaction here. Okay, so here's the reaction. What is going to happen here is that double bond you are seeing there is going to break. The double bond is going to break and it's going to open space. One space will be for the H and the other space will be for the OH. Now the hydrogen is always going to go to the carbon that have more hydrogen. In this case they have the same number, so it's not a big change, but always the hydrogen go to the carbon that has more hydrogen. In this case all of them have the same number of hydrogen, so it's not a big problem. But please note that on the OH is going to go to the carbon that has least hydrogen. So in this case it doesn't matter because they have the same number. Each carbon have one hydrogen. So hydrogen is going to one of them, either one, and the OH is going to the other. So the OH is going here. Now the question is not about this one. The question is about the type of alcohol. You can see that the carbon that is bonded to the OH is bonded to two other carbon. Therefore this one is a secondary alcohol. So what we have to say, secondary alcohol, because the carbon atom carrying the OH is connected to two other carbon. Guys, it is shown here in the structure. You can see it quite simple. Write down the structure of the formula of compound B. Compound B, we already write it there at the bottom. We can have it here real fast again. Is the 4 carbons here. The OH was right there, and then everything is hydrogen. This one is the alcohol we are talking about. It was written down there by the answer of the reaction, but let's write it here. During reaction 4, now what is reaction 4, guys? We have an alcohol there and we are adding now a carboxylic acid. So this compound is an ester without saying much, and reaction 4 is an esterification. That is esterification, and compound C is going to be an ester without even reading more. Okay, so now during reaction 4, a mesh of 7,4 grams of compound B, which is the alcohol, reacted with 3 grams of ethanoic acid. Write down the homologous series to which compound C belongs. We already say it. is an ester. That is the homologous series. Write down the name or formula of the catalyst needed for this reaction. And the catalyst needed is sulfuric acid. So in this case is H2SO4. They say name or formula. So I'm going to write the formula there, but you can write the name as well. Question 4.3. It is found that only 2.5 grams of compound C formed during the reaction. Calculate the percentage yield of the reaction. Quite good calculation here. Okay guys, now to answer this question we are going to do the reaction. We're going to see the chemical equation. You have that the alcohol is reacting with the carboxylic acid to form water and an ester, and the ratio, as you can see there, is 1 to 1 to 1 to 1. So everything is 1 there, and the ratio is quite important. Now in this question they say that 7.4 grams of compound B, which is the alcohol, so this one was mass equal to 7.4 grams, react with 3 grams of ethanoic acid. So the mass of ethanoic acid is 3 grams, guys. Now, the first thing you always have to do is to calculate the number of mole of each of them. So this one is mass divided by molar mass, as well as in the ethanoic acid. Now all we have to do is to calculate the number of moles. So let's do that real fast here. So here in the case of the alcohol we have that is 7.4 divided by the molar mass of the alcohol. Let's do it real fast. This is 4 times 12, which is carbon, plus 9 times 1 for the hydrogen there, plus 16 plus 1, which is for the last hydrogen, guys. You must do like that. And then guys, this one will be 7.4 divided by 74, and then the answer is going to be 0.1 mole. So you will have 0.1 mole of the alcohol. Now we are going to do the same for the acid. So number of mole is equal to mass of the acid that reacted there divided by the molar mass. So what we substitute here is going to be 3 divided by the molar mass of the acid, which is 12 for 1 carbon there, plus 3 times 1, that is for the 3 hydrogen, plus 12 plus 16 plus 16, I'm going to write it at the bottom here, plus 1. That is what you get there. So the number of mole, guys, when you calculate it there, is going to be equal to 3 divided by 60. Make sure you do the calculation correct. And then you get that the answer here is 0.05 moles. Alright? So this is the number of mole of ethanoic acid you have at the beginning. So if you use the ratio here, guys, the ratio of the alcohol and the acid, the ratio is 1:1. So we're going to substitute either one. And for instance, if we have 0.1 mole of the alcohol, how much acid do we actually need to use up all that alcohol? And this one is the whole cross product is quite simple, so you will need actually the same amount of mole of acid. But the problem here is that you don't have so much, you only have this amount. Now this one means that the acid is the limiting reagent. That acid is the limiting reagent and is therefore the amount we have to use to do the calculation. So now, using the limiting reagent, guys, we cannot use the one that is in excess. We are going to determine the question they're asking us, which is the percentage yield. But we need to know how much of this one can we form using this limiting reagent. So now we are going to use another ratio again. So in this ratio, we are going to be use the carboxylic acid and the ester. And what we need to know, if we have 0.05, which is the amount we have the that is the amount that was used. You have to use that one. How much of the ester will you form? The ratio is 1:1, guys, so that will be the same amount. So the number of mole of this compound C is going to be equal to 0.05. That is the number of mole that is going to actually be produced when you use that amount of carboxylic acid. And from here we can say the number of mole is equal to mass divided by molar mass. We're looking for the theoretical mass of the ester, which in this case is that mass. So this one is 0.05 equal to mass divided by the molar mass of the ester. In this case will be 6 times 12 plus 12 plus 2 times 16. That will be the molar mass there. So guys, from here you will get, this is simple calculation, you will do it. I trust you are able to do that calculation. Then the mass is going to be 5.8 grams. Now this one that you calculate is the theoretical yield. That one there is the theoretical yield. So how do we calculate the percentage yield? Percentage yield is going to be equal to actual yield. I'm going to write AY, follow me so you can know what is the meaning of that one, divided by the theoretical yield multiplied by 100. This one is grade 10 work. So percentage yield is equal to actual yield, which was 2.5. That is what the question said. No, the question said that it is found that only 2.5 grams of the compound was produced, divided by the theoretical, which is 5.8 multiplied by 100. And this one will tell you that the percentage yield is equal to 43.1%. Guys, it's a low yield, but that is the question. It is a very good question to practice because we don't do stoichiometric that much. Let's continue with the question. And then for this question is reaction 5. Now if we go to reaction 5 here, you're starting with an alkane and you have an alkenan compound. Guys, remember the alkane was butane and you have ethene, so compound E must be what is left over there. Is not that bad. So you can actually see that this reaction 5 is going to be cracking. That is the important thing. It's cracking, and to be specific, because it's done at heat at high pressure, is going to be the thermal cracking. It's going to be thermal cracking. That is important to know. So from butane we end up with butane plus compound E, guys. It's not that bad. So let's go to the question here. The question said type of reaction with thermal cracking. And then to finish here is balance equation using structural formula. So let's do the balance equation for the cracking of butane. Okay, so we're starting with butane, and we know that one of the product is ethene. Let's go back here to the chart. You can see here that one of the product is ethene. The other product we don't know. We're going to find out real fast. Okay, so we know that we have already taken 2 carbon from here, from this butane. So 2 carbons are left. There are 2 carbon left, guys. Now, how many hydrogen? We took 4 hydrogens, and therefore we have 6 hydrogens left. So when you come here, if you combine this one and you give 1 hydrogen to each carbon there, guys, this one is what we have. Then we combine with a single bond, guys, and this is in actual fact that final compound that we did not know, which is compound E. And this is the answer, but the answer is not about compound E, it's about finishing the balance equation. And there we go. If we count, we can see that we have the same number of atoms of reactants and product. Guys, this is the end of this question. It is the actual very good question to practice about reaction. I hope it helped. I hope you understand. If it is so, please subscribe for the channel, thumb up. I'll see you next time. Mr. G here.